So welcome to this latest video on 162 Maths, and in this video we'll be going over the AQA AS Maths past paper of June 2023, paper 1 section A, which is the pure section. Now before we get started working through this paper, a little reminder that I will include a question breakdown in the description below so you can see what question refers to what topic should you get stuck on any of the questions. And I'll also include a link to the 162 Maths contents page, which has access to all of the topics that go through them in greater detail. So should you find needing any help or unsure about particular topics that are covered in these questions, I would strongly recommend checking out lessons so you can kind of remind yourself of its contents. So starting on question 1, it says at a point on the curve the gradient of the tangent to the curve is 10. State the gradient of the normal to the curve at P and you need to circle your answer. So here if we know that the gradient of the tangent is 10, then we know that the gradient of the normal is the negative reciprocal of the gradient of the tangent. So here what we need to do is if the gradient of the tangent is 10, we just then need to do minus 1 over 10 and then convert that into a decimal as they're all in decimals, which gives us minus 0.1. So we're circling our second option. Then for question 2, it says identify the expression below which is equivalent to 2x over 5 to the power of minus 3. Now it doesn't really matter what order you do this, either you can handle the negative or you can handle the power of 3. It's entirely up to you which one you prefer. I personally prefer dealing with the negative first because that's often where students tend to forget to recognise that. So here when we've got negative power we flip the fraction, so that then becomes 5 over 2x to the power of 3. And then all we then need to do is just cube everything. So here we've got cube of 5, which is 125, over the cube of 2, which is 8, over the cube of x, which is x cubed, and that is our third option. Moving on to question 3, it says the coefficient of x squared in the binomial expansion of 1 plus ax to the power of 6 is 20 over 3. And the question is asking us to find the two possible values of a. Now again, you might have your own method of how you expand binomial expansion, but here I'm going to go for three options. Well, my option I go for, which is first of all to do the Pascal coefficient, which is 6, 0, and then 6, 1, and then 6, 2, which will be our coefficient of x squared. We then move on to the power. So here we've got the first term. So that first term starts high, so that's going to be 1 to the power of 6. And then the second term will be 1 to the power of 5. And then the third term is going to be 1 to the power of 4. And then it's dealing with the second term in the bracket, which in this case is ax. And that starts low, so that'll be ax to the power of 0. Then ax to the power of 1. And then ax to the power of 2. Now from the question it tells us that this third term, or this here, is equal to 20 over 3. And that is what I'm going to be looking for. So again, if you're not sure on how to do this, so this would be the coefficient of the constant. That would be the coefficient of x, and this will be the coef of x squared. So taking this, what do we have? Well, if I just simply type that all into my calculator, I'm going to end up with 15 multiplied by 1 multiplied by a squared x squared equals, oh, don't know what's happened there, equals 20 over 3x squared. Now from this, what I can then do is just get rid of the x squared from both sides. And it just makes it a little bit easier for me to find out what a is going to be. So here I'm going to be left with 15a squared equals 20 over 3. And all I need to then do is just do a bit of rearranging. So here I find that a squared is going to equal 4 over 9. So therefore a is going to equal plus or minus 2 over 3. Now moving on to question 4, it says it is given that 5 cos squared theta minus 4 sine squared theta equals 0. Find the possible values of tan theta, give your answers in exact form. So for this, all we need to do is basically, because we're dealing with tan and we've got cos and sine, we just need to combine those two. So here, if I just write down the equation of 5 cos squared theta minus 4 sine squared theta equals 0. Take this over to the other side, so end up with 5 cos squared theta equals 4 sine squared theta. Then take the cos squared over to the other side and the 4 over to the other side, and what we'll end up with is 5 over 4 equals sine squared theta over cos squared theta. Then from this, what we then know is that cos squared sine squared theta over cos squared theta equals tan squared theta, so 5 over 4 equals tan squared theta. So therefore we then get tan theta equals the square root of both those sides. It'll be plus minus the square root of 5 over 4. Now because it asks for the exact values, we then need to simplify this, and because we know recognise that 4 is a square number, we can then write our answer as tan theta equals root 5 over 2, and that's going to be plus or minus. So again, you can either write your answers both for the 3 marks, but definitely don't use your calculators to simply use your ST function to convert it into decimals. So I'd say any of those 2 answers would be absolutely fine. Then moving on to B, it says hence or otherwise solve the equation, and we've got the same equations we had in part A. Give all the solutions of theta to the nearest 0.1 degree in the interval between 0 and 360 inclusive of those numbers. Now again, it's entirely up to you how you get these answers. I know a lot of students are taught how to use cast. I personally prefer using the graph. So here, if I do a sketch of tan theta, and let's just do the dashed intervals. So what it eventually looks like is it looks something like this. Like so. And plus or minus root 5 over 4 is basically going to give me a set of answers here. So this is, we've got plus root 5 over 4, and here we'll end up with minus root 5 over 4, in which the values of theta we should have to one decimal place will be 48.2 degrees and 228.2 degrees, and another set of values of 131.8 degrees and 311.8 degrees as our 4 possible answers. Then moving on to question 5, it says for A, given that y equals x root x, find dy dx. Now for this, what we need to do first is we need to write this using index notation. So here we've got that y equals x multiplied by x to the power of a half. Now if I just stick a 1 there, what we then need to do is just simply simplify all of this. So here we add the powers when we're multiplying, so that's going to give me x to the power of 3 over 2. So then from this, what I can then do is I can then differentiate y equals x to the power of 3 over 2. So here I move the power to the front, divide by the new power, so dy over dx is going to equal 3 over 2 x to the power of a half. Now, or you could write it as a decimal, which I wouldn't encourage, but if you wanted to, you could write it like that, but personally I would leave it in that form. Now moving on to B, it says the line L has the equation of 6x minus 2y plus 5 equals 0. L is the tangent to the curve with the equation of y equals x root x plus k. Find the value of k. So the first thing we want to do here is we want to find the gradient of this line here, because that is what's going to be equal to our dy dx of what we found in part A. So here, finding the gradient, so we've got 6x minus 2y plus 5 equals 0. So I get 2y equals 6x plus 5 by taking the y over to the other side. And then what I end up with is y equals 3x plus 5 over 2. So here our gradient is going to equal 3. Now dy dx is our gradient function, so therefore if we've already worked out what dy dx is, which is our answer in part A, So then what we've then got is 3 over 2 x to the power of a half equals 3. Now doing a bit of rearranging, what we can then do is then solve this for x. So here I've got x to the half equals 3 over 3 over 2, and then x equals the square root of the answer. We get an x value of 4. So then here what we need to do to find k is we need to find our y ordinate and our x ordinate. So here I've got x equals 4. So now what's left for me to then do is find the y ordinate. So then using 2y equals 6x plus 5, and that's just taken from this line here. We know that when x equals 4, what we need to do is now find y. So substituting x into this, we get 2y equals 6 times 4 plus 5, which gives me a y value of 14.5. So then I've got my two y ordinates, so all that's left for me to then do is to now substitute those x and y ordinates into this equation. So we know that y equals x root x plus k, x equals 4, y equals 14.5. So here I get 14.5 equals 4 root 4 plus k, and that's going to leave me with a k value of 6.5. Moving on to question 6, it says in part A that the curve C1 has the equation of y equals 2x squared minus 20x plus 42. Express the equation of C1 in the form of completing the square, where a and b are integers. So all we need to do here is perform completing the square on this equation here. So the first thing I need to do is factorize with respect to x squared. So here I take out the 2, so I'm left with x squared minus 10x plus 21. And then what I then want to do is now use completing the square on this quadratic expression inside the square bracket. So I've got 2, and then I've got x minus 5 squared plus 21 minus 25. And so y equals 2, and then just neatening it what's inside my square brackets, I'm going to get minus 4. And then multiplying out the 2, I get y equals 2 lots of x minus 5 squared minus 8. And there we've got our form. Then it then says write down the coordinates of the minimum point. Now remember that when we've got completing the square, our minimum point is going to be, or the vertex or the maximum point is going to be minus a b. So looking at the bracket, I'm looking for the x value that makes that bracket equal to 0, which is positive 5, and the constant at the end, which is minus 8. For C, it then says the curve C1 is mapped onto the curve C2 by a stretch in the y direction. The minimum point of C2 is at 5 minus 4. Find the equation of C2. So here, if we had an original centre of 5 minus 8, and that's now been changed to 5 minus 4, then what we know is that that is a scale factor of a half. So therefore what we've then got, if I take the original equation, so I've got x, and then I want to take that to a half, and multiplying that by the original equation, which is 2 lots of x minus 5 squared minus 8, and then multiplying everything by a half, I'm going to end up with y. Half times 2 is just 1, so that's going to be x minus 5 squared, and a half times 8 is going to give me minus 4. And then just expanding this out and simplify, I'm going to get y equals x squared minus 10x plus 21. And there we go. Now moving on to question 7, it says points P and Q lie on the curve with the equation of y equals x to the power of 4. The x coordinate of P is x, and the x coordinate of Q is x plus h. And the first question for A is asking us to expand x plus h to the power of 4. Now again, separate different ways in which you can do this. You can either just simply expand the brackets with 4 brackets and just use traditional methods to work it out, or you can recognize that this is a binomial expansion. Now for this, whichever method you use, as long as your final answer is correct, you will get the 2 marks. So for this, I'm going to use binomial expansion. So here I've got, so for the first one, we've got 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. And then I'm going to multiply that by the first term, starting with the power high. So that's going to be x4, x3, x2, x1, x0. Then for the third term, which is just h, I'm going to multiply that by h. And again, for the second term in the bracket, that starts low. So that's going to be to the power of 0, 1, 2, 3, and 4. Then if I work each of these lines out using Pascal's coefficient or Pascal's triangle, basically we're going to get 1 times x to the power of 4 times 1, 4 times x to the power of 3 times h, and we're going to get 6 times x squared times h squared, and then 4 times x times h to the power of 3, and then we've got 1 times 1 times h to the power of 4. If I simplify each of those lines, I'm going to end up with x to the power of 4, 4x cubed h, 6x squared h squared, 4x h cubed, and h to the power of 4. And then all that's left for me to then do is add all of those terms that I've written here into a single line. So that's going to equal x to the power of 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the power of 4. And again, when doing that, make sure your x's are like x's. Do not confuse them with the multiplying. Then for B, it then says, hence find an expression in terms of x and h for the gradient of the line PQ. Now remember that the gradient is equal to the difference in y over the difference in x. So again, remembering differentiation by first principle. So what you should end up with is x to the power of 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the power of 4, all divided by h. Then for 7c, it says explain how to use the answer in part B to obtain the gradient function of y to the power of x to the power of 4. So here, as we know that as h tends to 0, then what we then need to do is basically use first principle. So here it's the difference. Actually, I forgot the minus x to the power of 4 there, because that was our original x value. So then from this, what we can then do is, if I just write down our answer in part B, all over h, then what we know is that this x4 is going to cancel with this x4, and then from this what we can then do is cancel a h. So here we've got this cancels with this, cancels with one of those, that turns to a 2, and that turns to a 3. Now, as you mentioned, as h tends to 0, then everything with a h tends to disappear because it's been multiplied by 1. So all we're left with is 4x cubed, and there is our gradient function of y equals x to the power of 4. Now moving on to question 8, it says for A, show that, and we've got an integral of 6 over 12 root x dx equals 6a minus 24 root a plus 18. So if we take this integral here, and let me just write that out again. So we've got integral of a to 1 6 minus 12 over root x dx. And then what you want them to do for here, so to integrate this, we need to write this using index form. So I've got a1, and I've got 6 minus 12x to the power of minus a half dx. And then if we integrate this, remembering the rules of integration is we increase the power by 1, divide by the new power. So what's that going to look like? Well, it's going to look like, let me use a different colour pen so we can see it clearly. So we end up with 6x, and then it's going to be minus 12x to the positive a half over a positive a half, and then we've got our limits of a and 1. So then working that out, and substituting the values of a and 1 into our expression, we end up with 6a minus 12a to the power of a half over a half minus, and then it's going to be 6 times 1, which is 6, minus 12 times root 1, which is just 12 over a half. And then simplifying all of that, what do we end up with? Well, we're going to end up with 6a minus 24 root a, or root x, root a, and minus 6 over 24. Oh, let me just prove the presentation there. Which is then going to give us an answer of 6a minus 24 root a minus 6 plus 24, which then therefore equals 6a minus 24 root a plus 18, which is what they wanted me to show. Then moving on to B, it says the curve of y equals 6 minus 12 over root x. The line x equals 1 and the line x equals 8 are shown in the diagram below. The shaded region of R1 is bound by the curve with the line x equals 1 and the x-axis, and the shaded region of R2 is bound by the curve, the line x equals a and the x-axis. It says that it's given that these areas of R1 and R2 are equal. Find the value of a. So for this, if I just zoom out so we can see the questioning on the screen, and I'll just try and do the working out on the side. So here we know that if equal, then if we have a and 1 f of x dx is going to be equal to 0. So when I actually work out the f of x function from the limits of a to 1, it's going to equal 0 because R1 is equal to R2 in terms of the area. So therefore, that then says, so we know we've already integrated f of x to the limits of a1, which is our answer in part A. So that means that 6a minus 24 root a plus 18 equals 0. Then if I divide everything by 6, I end up with a minus 4 root a plus 3 equals 0. Now this is what I now need to solve. Now the problem with this is that although it kind of resembles a quadratic, it doesn't actually look like one. And again, because you're not seeing a power, what do we do? Well, if I make a equal root k, then what we end up with, let me use a different colour, so let's get rid of the orange, let's use blue. So here, if k equals root a, then what this is then going to be is k squared minus 4k plus 3 equals 0. And here now what we've got is our quadratic. So then I can then factorize this or go on and solve it. So I've got k minus 3, k minus 1 equals 0. So k either equals 3 or 1. So therefore root a equals 3 or root a equals 1. So therefore a is going to equal plus or minus 9, or actually that's going to equal minus 9, it's going to be positive 9 because we're looking at a square root. So it's either equal 9 or 1. Now it can't equal 1 because 1's already taken by R1, so therefore a must equal 9. And there we've got our value of a. So moving on to question 9, it says a continuous curve has the equation of y equals f of x. The curve passes through the points a21, b45 and c61. It is given that the first differential of f to 4 is equal to 0. Jasmine made two statements about the nature of the curve y equals f of x at the point B. Statement 1 is that there is a turning point at B, and statement 2 is that there is a maximum point at B. So for question 8 says, draw a sketch of the curve of y equals f of x such that statement 1 is correct and statement 2 is correct. So for this, all we then need to do is basically draw a parabola. So we've got a turning point at B and it's a maximum So it should look something like that. Then for B, it then says draw a sketch of the curve y equals f of x such that statement 1 is correct and statement 2 is incorrect. Now again, remember that the two statements were that there is a turning point at B, and statement 2 is that it's a maximum at B. So what I want to show is that it's a minimum at B. So what would that look like? Well, it would look something like this. So we've got a turning point at B, but you can see here in this diagram, the curve that I've just drawn, that B is a minimum. Then for part C, it says draw a sketch of the curve of y equals f of x such that both statements are incorrect. So we don't want a turning point at B, and we definitely don't want a maximum at B either. So for this, it's going to be something that looks like, so we haven't got anything there, and it kind of looks like that kind of curve there. Something along those lines where A and B doesn't have any turning point, no points of inflection or anything like that, and it's definitely not a maximum point, but then eventually it goes down to C. Now looking at question 10, it says that Charlie buys a car for £18,000 on the 1st of January 2016. The value of the car decreases exponentially. The value of the car is £12,000 on the 1st of January 2018. So for part A, it says Charlie says that because the car has lost £6,000 after 2 years, after another 2 years the car will then be worth £6,000. Charlie's friend Kaya says that because the car has lost 1/3 of its value after 2 years, after another 2 years it will be worth £8,000. Explain whose statement is correct, justifying the value they have stated. So for this, what you want to say is that here we know that Charlie is going to be wrong. So Charlie is wrong. And the reason for this is because it's decreasing exponentially. So if we have a little graph where we've got time and we've got value, it's going to go something like this in terms of the graph. Now, actually, it's not going to look like that. It's going to look like this, where only after a certain amount of time will the decreased amount be quite proportional, be quite linear, because again, initially it's not going to be like this. Now again, we don't know whereabouts of the car Charlie has bought the car, like how old the vehicle is. So all we know that 2016 could be here, it could also be there, in which then the amount could be the same. But the problem is we don't know the age of the actual car. So for this, we know that Charlie is wrong, Kaya is correct. And again, if we then just do 2/3 of 18,000, we get 12,000. And if we do 2/3 of 12,000, we get 8,000. So given the choices between the two, K is going to be correct. And moving on to B, it says the value of Charlie's car in V pounds t years after the 1st of January 2016 may be modelled by the equation of V equals A e to the power of minus kt, where A and K are positive constants. And the question is asking us to find the value of t when the car has a value of £10,000, giving our answer to two significant figures. So for this, what we know is that A, which is the initial price of the car when Charlie bought it, is £18,000. We know that t equals 2 years, and we now know that the value that we want is 10,000. It's 12,000. So in terms of this, what we then need to do is, first of all, we need to find the value of k. So substituting those numbers in, what do I get? Well, I'm going to get 12,000 equals 18,000 e to the power of minus 2k. Then doing a bit of rearranging, we get that e to the power of minus 2k equals 12 over 18. Let's just stick the 0 so you know where that's come from. And then we then get minus, if I take the log of, well, let's simplify this. So we get 2k minus 2k equals, so take logs, or take the ln of both sides. We end up with ln of 2 over 3, which is 12,000 over 18,000 simplified. Then from this we then work out the value of k, so it's going to be ln of 2/3 divided by minus 2, so therefore that gives me a k value of 0.203, which I'm just going to write to 3 decimal places. So from this, what we then can do is we can then write down the formula which is v equals 18,000 e to the minus of, and it was kt, so it's 0.203 multiplied by t. So this here is my formula. And then what I then want to do is I then want to make v equal to 10,000. So when v equals 10,000, we get 10,000 equals 18,000 e to the minus of 0.203 t. And then solving this in terms of just rearranging, so we get 10,000 divided by 18,000 equals e to the minus 0.203 t. Then we can take the ln of both sides, so ln of, I'll just simplify this as 10 over 18, which is 5 over 9, equals minus 0.203 t. And so therefore t equals to two significant figures, 2.9. And there we go. Then moving on to part C, it says give a reason why the model in this context may not be suitable to calculate the value of the car when t equals 30. Now again, trying to find the value of a car when it's 30 years old is a couple of things using a particular model, that the car will probably be scrapped because it may not even be worth any value after 3 years. You could say or unusable, stroke drivable. You could say something along the lines of that gives an unrealistic value. So if I substitute t equals 30 into the formula, unrealistic value, and if I substitute t equals 30 into the formula, it gives me a value of £41. And again, is the car going to be worth £41? No, it's probably worth more in parts than it would be actually driving. So you could pretty much say the car will be worthless. So something along those lines would be absolutely fine for the 1 mark. Then moving on to question 11, it says that a circle has the equation of x squared plus y squared minus 10x minus 6 equals 0. Find the centre and the radius of the circle. So for this, all we need to do is then just factorise using CTS, completing the square to then get it in the format of our brackets. So again, just rearranging, I've got x squared minus 10x plus y squared equals 6, and then factorising the pairs, I get x minus 5 squared minus 25 plus y squared equals 6, and then rearranging this, I get x minus 5 squared plus y squared equals, and that's going to be 31. So therefore the centre is going to be at 5, 0, and the radius is going to be root 31. Now moving on to part B, it says an equilateral triangle has one vertex at the origin and one side along the line of y equals 8 as shown in the diagram below. And it says for part 1, it says show that the vertex at the origin lies inside the circle of x squared plus y squared minus 10x minus 6 equals 0. So for this, what we need to do is we know that the centre of the circle is here, and we know that the distance from the origin to the centre is 5. So therefore, if this distance here is 5, and we know that the radius of the circle, so the distance of the origin to the centre equals 5, we know that the radius of the circle is root 31. So as root 31 is greater than 5, we know that the origin is inside the circle. Then for part 2, it says prove that the triangle lies completely within the circle of x squared plus y squared minus 10x minus 6 equals 0. Now for this, I'm going to do this over here, and let me just get rid of all the markings that we can see. just so that I can use the diagram for C. Now for this, what we need to do is we need to find out the height of this triangle. So if I just call that y, and now you might think that it does equal 4, but again the diagram's not equal to 0 and we don't know what the lengths are. All we know is that this there is the origin. Now if it's an equilateral triangle, it means that this angle here is going to be 60, which therefore means that this angle here is going to be 30. Now we know that this length here is 8, so then using trig, what we can then do is to find what the y-ordinate of this is going to be, is we can then use just SOHCAHTOA trig. That's 30, that's 8, that's y, so we've got tan 30 equals y over 8, so y equals tan 30 multiplied by 8, so y is going to give me a value of something around 4.618 blah blah blah. So this coordinate here is 8, 4.618 blah blah blah, and that's what this point here is. So then all that's left for me to then do is to then work out the distance from the center to that point there. So if I just call this C and let's call this A, so we know that this length here is 4.618. I now need to work out what C to A is. So then using Pythagoras, so if I just call this, let's say K, we know that this is 4.618 blah blah blah. We know that this distance here is 3 because it's going from 5 to 8. So then what we've then got is K squared equals 4.618 squared plus 3 squared. So then that's going to give me a K value of, and again just substituting that all in, so 4.6188 squared plus 9 and then square root the answer. It gives me an answer of 5.507 and something along those lines. So then all that's left for me to then do is compare this to the radius of the circle. So therefore, as 5.507 is less than root 31, we know that, and again this is going to be exactly the negative distance from there, the triangle lies inside the circle. And there we go.